All right, so here we have the inverse trig functions. So the inverse trig functions, so the inverse trig sine, so we say this, arc sine. Notice that this, same thing as this is not 1 over something, this is the inverse. Technically, oops, technically we also call these arc sine, or arc cosine, or arc cotangent, just in case to remove that confusion. This has a domain between 1 and -1 and a range of minus pi over 2 to pi over 2. So if you remember from your trig days, right, your inverse sine gave you answers in this part of the unit circle. So you had 1, 2, this was 3, and this was 4. And so, and since sine can only produce values between -1 and 1, right? That's the domain. So that's all I'm allowed to plug in here. And then the range of this, well, it's going to give me values for here, right? Depending on what we get. And so we have the cancellation properties. And notice the cancellation properties are kind of particular on which one we put in first. So if I take the inverse sine first, I can only have, it'll give me, and then take the sine. This will only produce me answers between -1 and 1 for x. And then here, if I take sine first, I need the inverse sine. Since the inverse sine only has a range between here and here, this is only going to work. Cancellation properties only work for this domain. So this is just something to be aware of. So we're going to do a sine, and we're actually going to truncate these. So when we do this, so sine is not 1-to-1, right? Sine is clearly not a 1-to-1 function. It goes on forever and ever, right? Because here, if I was going to draw it, it goes something like, oops, let me do it. So sine goes up, comes down, comes up, goes down, goes up, goes down, right? So that's what sine looks like. But we can't, this is clearly fails the horizontal line test. So what we do, so we're going to show the truncation. So we're only going to just go up to pi over 2. We're going to go down to minus pi over 2. And so here's what we're going to use. We're going to truncate sine to only this. And this is between -1 and 1. So inverse sine is just a reflection of that. And so it looks kind of like this, where this is -1, and this is 1. And then here, this is minus pi over 2 to pi over 2. So that's what we do. All right. Some of your homework's just crunching through some of the numbers. And so just go ahead and use a calculator for these. So inverse sine basically ask what angle. So basically this is asking sine of y gives me a half. And so inverse sine of half will give me y. And so what sine gives a half? Well, if you remember your I as your unit circle, you realize this is just pi over 6. It's pi over 6, right? And here, where does it give me in minus half? Notice this would be minus pi over 6. What happens if I want to find the inverse sine of 3 halves? What happens here? Let's see what the calculator gives us. Let me show you how to type this in. When I'm typing this into Wolfram Alpha, I don't want it that big. I just don't. When I type this into Wolfram Alpha, I always type in arc whatever, right? And so here I'll type in arc sine. And here we'll just go ahead and let's just go ahead and check the other two real quick. So we have a half. That gives me pi over 6. I have minus a half. This gives me minus pi over 6. And if I type in 3 halves, notice that's outside of my domain. So it should tell me not defined, right? And so here, oh, I was like, it should tell me not defined. And I'm glad I typed it in the calculator. I really am. This is not a real number, right? This is undefined, right? So we're going to write undefined. Can you technically do it outside of the real numbers? Yes, but we're not going to do that in this class. So this is undefined because it's outside of its domain, right? It's outside of its domain. Here we're going to strictly declare the domain, right? All right, let me leave that for 1 second. I'll get to the next page. Trust me, we can do the next page in the same amount of time. All right, so here, sine of a third. These will not always give you clear answers. All right, hold on, come back here. So let me just type these in with you and show you the answer. So here of 1/3, 1/3 does not give me a nice clean answer. It just doesn't, right? It's not anything super clean. It's some decimal, right? So this is 0.3. Let's just put 0.340. This is 0.340. And it's going to give you answers in radians. Now for B, we assume when we plug in arcsine of a sine of pi over third, we get pi over 3, right? And that's what we'll actually see that. Sine of pi divided by 3. And so if I plug this in, arcsine of sine of pi over 3 is pi over 3. But here, if I type in arcsine of 2 pi over 3, this does not give me back 2 pi over 3. It gives me back pi over 3. And so just be very, very careful when you cancel, because this gives you, these both give the same answer, but notice how this is not. And the reason that is because that is outside of my cancellation property, right? 2 pi over 3 is much outside of this. And so when I do this, this is a valid operation. It's just going to give me a smaller number back. And so just be careful when you're using the inverse trig functions. And we'll end on this one. So here's inverse cosine. Here it has the domain between -1 and 1 and range between that. Remember, your inverse cosine gave you answers in the first and second quadrant from your trig days. And here we have the same sort of cancellation properties. And so cosine, if we truncate it, cosine starts at 1, and we're just going to do 1 like this. And so here's one thing of the cosine. And so this goes from, this will be pi, this will be pi over 2, of course, and this is 0. So if we truncate it this way, our arc cosine function looks like this. This was pi, it comes in, comes through at pi over 2, and then here, and this is at, of course, -1 and 1, okay? And so this is what the arc cosine function looks like. And this, to finish up, almost, I might go 1 second over, guys. I might go 1 second over, but we'll finish this page. Can I see page? I'll go back to the first one. Yeah, I'll go back to the first one. And then I'll answer all you guys' questions. So let's just type this in. So now instead of arc cosine, I'm going to use our arc sine. I'm going to do arc cosine. All right, so arc cosine of pi over 3 should give me, or 3 pi over 2 should give me pi over 6. I'm not crazy. So SQRT 3 divided by equals pi, or no, over 2. Sorry, I'm trying to answer the question, not typing what I want. And yeah, we get pi over 6. Okay, because that's answering here, minus 5 divided by 7. Here we're going to get some real answer, which is about 2.33 or 63, 2.366. This is pi over 6. This is about 2.366. And what do you think we're going to get here? Am I going to get 5 pi over 3? And the answer is no. What was the stray division? Let me answer this question real quick, and I'll answer all the, let me finish this last one real quick, and then I'll answer all you guys' questions. That way you get, if those need to go, can go. This would be 5 pi divided by 3. So notice that this is not going to cancel properly, and this is just going to give me pi over 3. Okay. So be very careful that these don't directly cancel. And so I do that twice to show you. All right, so that's the end of these notes. Sorry, I went 2 minutes over. Okay, so let restart this. All right, so we're going to do a definition of the inverse of the tangent function. So tangent inversion, also known as arctangent, denoted as arctan. Most of the time you write it this way with the -1. So it has the domain of all real numbers, and the range between negative pi over 2 to pi over 2. And the reason that is because of, I can draw that for you. So if I just look at one period of tangent between pi over +2, pi over -2, I obtain, that should go through here, and this should be negative. So here, if I was going to draw that, so arctangent will look something like this, where I have minus pi over 2 to pi over 2. And so here in the arctangent function, it's unique that it can take in all values, right? And so here, the arctangent of x times the tangent is equal to x for all real numbers, and then for tangent, arctangent is only between negative pi over 2. So here's the cancellation properties. So let's talk about limit. So the limit for sine and cosine is x goes to negative infinity, and positive infinity is undeterminate, as we determined earlier. But for arctangent, and same for all the tangent, or for all the, but for the arc function, notice that I go to infinities, this looks like pi over 2. As I go to negative infinity, this gets really, really close to negative pi over 2. And so you can solve some things that look like this. So what do we have here? So here we're coming in. So we want to find arctangent of this. As x goes to the right-hand side of 2 of this number. Well, this number, I think I made a small error. Yes, I did. Hi, guys. This should not be a positive. This should be minus. Because if it's positive 2, it's just the arctangent of the fourth. It's not interesting. Switch this to a negative. And so here we're gonna look at, let t be the limit as x goes to negative 2 positive over 1 over 2 of x minus 2. Notice that this will be slightly positive. It goes to 0. So this goes to positive infinity. So we can rewrite this as the arctan. So the limit as t goes to infinity of arctan of t. Well, once we know what that is, it's right here. So this equals to pi over 2. And so we use this trick often in the last couple of sections, is like where something either goes, we have some function here that goes to either positive, negative, or infinity. If I take this, and then I want to take the trig function of it. And so you just do the replacement. You say t is equal to so t goes to this limit, right? And so you just replace t here. Because we let t, it approaches this, and so I guess the equal sign's not necessarily 100% correct. I should say let t represent this, and then as t goes to infinity, and do a replacement. Okay. All right, so that's the end of that. So I'll go ahead and let you guys copy that down real quick before I go to the next page. I've been talking for a while. You probably have it copied. So let's look at this. And so now, so there is an inverse secant, cosecant, and there's an inverse secant, cosecant, and cotangent. These are exactly what you expect them to be. They're just the inverse of these functions. Here I'm restricting my domain and stuff. And there's a derivative of all the inverse trigonometric functions. So all these inverse trigonometric functions have the derivative, and they're all just all these fancy formulas you'll find here. The book goes over the derivation of one or two of them. I wouldn't worry too much about it. And so let's just do a quick example. So let's find this derivative. So here I'm going to find, I forgot the arc sine. Sorry. This is what happens when I write notes. I miss stuff. So please put a -1 here. So this is the arc function. So here, if I want to find this derivative, it'll be, I'll let x be my f, and then the arc tangent of square root of x be my g. So f is equal to x, so f prime is equal to 1. G is equal to the inverse tangent of the square root of x. So g prime is equal to, well, here's the inverse tangent. So we'll have 1 over 1 plus square root x squared. And then the derivative of this, of course, is 1/2 x to the minus 1/2 power. The derivative of square root of x is the same thing as, remember, square root of x is equal to x to the half. So I pull down the half minus 1, so I get this. And then we just put it together. So it'll be f g prime plus f prime g. So we'll have x times the inverse tangent of x square root of x. Oh, no, hold on. G prime here, so it'd be 1 over 1 plus square root of x squared is just x. And we're going to multiply that by 1/2 x to the minus 1/2 power plus f prime times this will be just inverse x. And then here we can simplify this, so we can pull the 2 down. So I'll have, and put that in here, so this becomes square root of x over 2, 1 plus x. Okay. All right. So the book will ask you to do a couple of these problems. And so just so I can show you how to do them. Let me show you the way the book does it. And then I'll show you how I do it. Okay. So the way your book does it, it says, and your book does something mighty weird. I don't even know if I want to teach it. It's so strange. If you want to see how the book does it, just if you want to see how the book does it, go ahead and look at the book. I'm going to show you the way I would think to do it. And I would just think about this in trig, right? Instead of just take this. So the inverse, so this is going to give us some theta, right? So basically if I have tangent of theta is equal right here, which is, I guess we'll leave it as y. That's what your book's using. Oops, I don't want that big. This is equal to some y, right? Because tangent of y is equal to x. That means inverse tangent of x is equal to some y. So this is some y. And y is an angle, right? And remember what these functions originally means. It means y. And this is a ratio, something over something, right? And for tangent, it's opposite over adjacent, right? Opposite over adjacent. And so here I'll have x and 1. This is a right triangle, so I know what this is. It'd be 1 squared plus, it'd be the square root of 1 plus x squared, because it's a squared plus b squared equals c squared. I take the square root of that, so c equals the square root of a squared plus b squared. So I get this. And then I want to find cosine, and this becomes cosine of y. Well, cosine of y is just 1 over this, and so here I'll get this equal to 1 over, so adjacent over hypotenuse is just 1 over 1 plus x squared. Okay, so that's the way I've always done it. That's the way I've always figured it out and the way I've always done it.